Hi everybody, this is Chris Smith from the East Troy Computer Club. I'm going to try this again. I just went through, not that it's relevant, but I just went through recording and it didn't work. So I'm hoping it works this time. This talk was given August 8th, 2019 at the East Troy Computer Club. And there was a good conversation that was had. Unfortunately, the recording was not usable. So hopefully I cover everything I covered in the talk to make it as entertaining as possible here. This talk is going to go over using Excel and Google Sheets to call remote APIs. It's also known as, when am I ever going to need this? There's some interesting use cases, and we'll kind of take a dive into Excel a little bit, and also a dive into Google Sheets for calling remote APIs, and then I'll explain a couple business cases, and hopefully we'll talk more about APIs, and I'm interested to see what you guys build here. Now, the Excel has been around for a while. It was released in '82 as Multiplan. It started on the CP/M operating system, and that OS was built for the 8080 and the 8085 microcomputers or microprocessors. It was essentially a microcomputer in the 70s. DBase and several other word processors came from this era. DBase is that came from the 70s. And I checked on Wikipedia, and they're still around. They're still cooking. Their last stable release was like 2013, so very stable program, I guess. But I digress. Programming is built into Excel. You can do Visual Basic with it, and it was always kind of built in because that's how the control program multiprocessor OS worked. Essentially, you had to have those commands and things built in, so they just kind of made that available to users. Excel is not the first spreadsheet program. Spreadsheets have existed ever since we needed to keep track of money. On paper and pen, they've existed, and Excel just is the most ubiquitous. Maybe Google Sheets nowadays, but Excel kind of has seen some interesting changes. In the 90s, they started incorporating charts and graphs and really became the driver for business. Math is a huge part of Excel, but I would also state that math is essentially programming. It's a programming language. On the lower left, you could see that's you could generate a Fibonacci sequence in Excel, which is kind of cool. A little geeky and probably a little pointless, but there's a lot of things you could do in life that are pointless. Fibonacci sequence might be up there, but it's still geeky and cool. You can do practical things such as create invoices. My dad, for his business, when he was running a Commodore, had some type of spreadsheet program or some program that was used to generate invoices for his customers in the 90s. And then once he moved on to like Windows 3.1, he kind of used Excel at that point. And then other programs, of course. But you can quickly calculate up expenses. So there's my example on Google Sheets for remodeling a bathroom and kind of getting everything updated. And then you can quickly sum up the totals there and kind of create a budget. And you can also store a data set, and the data set being just any type of information. So I use Google Sheets to store addresses of families and friends and people we want to stay in touch with and make sure we have their updated address, whether it's an email address or a physical address. You could also store other information as a data set in Excel, such as a list of purchased items or a list of the things that you want to buy, certain goals, or like you see on the example, just a spreadsheet of expenses. And then you could have another column that actually has actual costs for what the project was. You can do some cool things in Excel. Just look and wonder. And if you recognize this is John Conway's The Game of Life recreated in Excel with macros. And it's kind of It's kind of horrific to know that that's possible, but it's also kind of awe-inspiring, maybe to some people, to know that. And you can research on what the game of life is. It's basically 4 simple concepts. Dark cells are alive, and or colored cells are alive, and white cells are dead. So that's an interesting way to put it. That probably gives some people the idea, saying, you know what, I can manage everything by a spreadsheet. And some people do. I'll give you a couple examples. The first one is actually probably what a lot of people do. They just use a spreadsheet as conduit for communicating information. This is one of my customers that has to communicate how things get packaged for their meals. And it's very important that they are packaged with a certain amount of labels and corrugates and stuff. But the interesting caveat to that is that if you just open this up and look at it, you have no idea what you're looking at. There has to be someone on the other side, almost like an interpreter, that says, hey, Chris, this is what this information means. If you don't have that conduit, if you don't have that person on the other side, that translator, you're lost. You're looking at it and guessing what it means, and you're getting overwhelmed with it. So Excel and spreadsheets are a great conduit for transmitting information. They're terrible for diffusing it, unless you have a book or a manual or some technical writer that can disseminate that information for you. And that's pretty true with everything in life. You know, if the technical writing isn't up to par, then you might not know what you're doing. So this next example, my friend asked what's out there in the Excel world that businesses use, like what's the biggest thing that businesses use. And I had this example from 2012 from a customer. I blacked out their names so no one throws pitchforks at them, because this is a workable solution. Just so you know, this is a solution. You might find it funny and hilarious, but it was something that was working for them at the time. And you can't argue with something that works for a business. You can always improve. And this is an entry tool for a time card for a company of 20 to 25 people at the time. They're bigger now, and I think that they are now no longer using Excel. But I was brought in because it was getting hard to manage this data set, and this is my first viewpoint into their world, which it was like, oh, okay, just a time card tool. Well, it's more than that. Everything in columns D through K, those are all macros, and the data lives elsewhere. So this is how employees got paid. They would enter in the category for their job, and this does job costing too. So enter in the job number, which on B8, that would actually do a type ahead for them, which is pretty remarkable to see all that code in Visual Basic. And then we're talking a lot of Visual Basic code to make this functionality work. Description pulls in and gets auto-populated. They punch in their hours. When they hit submit and save, it actually sends it to a different spreadsheet. And I don't mean a different tab on the spreadsheet. I mean a completely different file that's password protected, and because it has all the company information in it. It has all the hours. So it's insane that this thing got built, but it's awesome because someone actually built it out, and they created a solution for them and for their company. Now, it may just seem like it's a spreadsheet for time cards, but this company used it for everything. This is one little portal into the world. This is into the time card entry world. But they used this. They used another Excel sheet with other macros and a whole bunch of other code and spaghetti to basically manage jobs, job costing, do quoting, manage project names, do payroll. Everything was in Excel. Every single thing, which of course there's an XKCD about it. So it started with a lot of problems. Now after hours and hours of work, I have a lot of problems in a spreadsheet. So some people think that spreadsheets will fix everything. That's not necessarily the case. Sometimes you just create more problems. But it's business, and business evolves and has to evolve in order to keep business going. So that's the one thing I've learned over the years, is that Spreadsheets are an excellent conduit, and when people kind of scoff at spreadsheets or CSV files or whatever, that's the conduit that ties business together. Transitioning to APIs a little bit. APIs are kind of that developer's conduit that they can use to communicate between users or business to business or consumer to business, however they want. What is an API? An API is essentially just that middle layer that sits in between where the data set is. So that could be an Excel file. Most of the times it is a SQL database. But a lot of times too, like in that last case, it was literally just Excel files. And then it communicates to an app or to a website or something. Communicates to something. That's what an API is. The other aspect or the other side of an API that not many people think about is when you go to on your browser, Firefox, Chrome, whatever, on your phone, and it says, hey, we want your location, give it to us, that's important. And you select allow, that's actually, you're at the way end on Android or Apple or any browser saying allow, and then everything to the left of this is basically telling you, is basically communicating from the browser all the way back to Google or whatever is requesting that data, your location through GeoIP or your microphone access. That's an API between your browser and your operating system, and that's kind of cool to think about it that way. I created a product called Shipwise, and Shipwise is it's just an API. All it does is integrations. On the left side of this flowchart, you could see that the left side is an e-commerce system. On the right side is a warehouse management system. In the middle, the API or Shipwise communicates between them. That's all it does. It sounds simple, and the flowchart is overly simplified, but essentially on the left, the customer places an order, and that's the end of the customer interaction. Shipwise then pulls that order in through whatever means necessary, sometimes CSV files, and other times an API call, processes it, sends it to the warehouse, makes sure it gets shipped out, maybe sends an email to the customer or to the owner of the e-commerce site, and then sends that information back to Amazon, WooCommerce, whatever e-commerce platforms out there. So from the customer's perspective, they see, hey, order successfully placed. And then maybe a day later or hours later, hey, your order is shipped out. Here's your tracking number. But behind the scenes, it's the iceberg analogy. It's a lot deeper than just what the customer sees. And when those systems break down, it's the customer knows about it because they're not getting, hey, I didn't get my tracking number on that order, or I never got that email. Well, any one of these processes could break in between it. So just remember that APIs are they're fragile too. So I do like to flow chart out everything because it helps me get my mind around what direction I want to program in, and then it helps immensely with actually getting the website done. I'm not going to cover too much of this, but this is like the finished product, what the API actually looks like for developers. And remember, APIs are they're spreadsheets for developers. They're the conduit that developers connect other programs with. Real quick, what makes a good API? A good API is defined by Tim Berners-Lee with the 5-star data group, 5stardata.info. And it's just a 1 through 5-star ranking system. 1 star being not a great API, 5-star being a good API. 1 star is just you made your information available. You put it up in a PDF or an image and you put it online. Good. That means that some people can download it or share it, or and that's kind of it. They can't really do anything beyond that, like copy text off of it or anything like that. Maybe with a PDF, but that's beyond what makes a good API on the web. 2-star and 3-star are fairly similar. The only thing that differentiates it between the structured data is that it's non-proprietary. That would make it a 3-star. Now the publisher that is publishing this data, so if it's me through Shipwise, if I'm publishing data through Shipwise, it's pretty easy for me to get to a 3-star. it's just opening up the data and kind of putting it in place. Once I start getting to 4 and 5 star, it gets a little bit more complicated as a publisher. For a consumer, the benefits only get better. So if you're consuming this API, it gets easier for you. It gets there's more correlations that kind of get established. So 4-star is using the URI to denote things to people that can point to your stuff. So one example I gave during the talk was if you go to easttroy.org/events, that event list is going to change from time to time, depending on what concerts are in the area or what's happening on the square. That will change, on a daily or weekly basis. However, people can always go to easttroy.org/events and they'll see new things. So that's a 4-star API. And I know a lot of you are thinking that, wait, this is not an API. I can't connect to it with my PHP script or Python script, but I'll show you that it actually is an API, even if it's published online. So it doesn't just have to have some API key that you can access for it to be an API. 5-star is where you link data to other data. So like on the event page, you would link, like at the Farm Aid concert, you would link to the ticket, to where you could buy tickets on Ticketmaster. And that's linking your data to other data sources. The Shipwise example, just to go back to this, is if you fetch all the orders, you get all orders that are in Shipwise, you'll get a return value that shows, it'll show you, that this order links to this tracking number. If you want to find out the tracking number, call this request, and it gets you all that information. That's linked data. Or knowing where it came from, knowing that this order came from Amazon, and here's the URL that you can get to pull up that more order information from Amazon. So that's what 5 is for linked data. So an API, a good API is something that organizes that information and is able to relate the data, I guess. And what I mean by that is make relationships based off the data. So like on the Shipwise example, relating the tracking number to the order and tying it all together with the canonical source, which is Amazon or WooCommerce or wherever. From the Farm Aid example, which I'll show you next, it's relating the date, when the start date of the event is, where it is, what the ticket prices are. A lot of this information comes from schema.org, and not from schema.org, but schema.org is the authority on how the information relates. And I'll show you an example on that after I'm done with the slides. Farm Aid, if you Google for any event, you'll probably see like these boxes that pop up towards the top. So Farm Aid 2019 will be at 12 p.m. Saturday, September 21st. The location on the right is at Alpine Valley Music Theater in Wisconsin, and here's who it was founded by. Now, this information just doesn't come out of thin air, and it's obviously published. This is linked data. So this is, and however they link it is really up to them, up to the publisher, and also Google and other crawlers and search engines. When they find that data, it's up to them on how they want to display it and present it. But when you see data like this, understand that this is linked data, and you can make your website run better and be friendlier for customers or users or visitors by offering linked data. I'm going to skip this next slide just to kind of cover linked data because it's a little out of order. This is what it would look like on their website, just as a crude example. On the left-hand side, you see that this is just HTML. As a class of event-date and event title, that's all linked data. That tells the crawlers saying, here's the date that this event is going to take place. And it's in a standard format. And here's the title. Here's the venue, the div class of address. It knows where it needs to be. Here's the ticket information. So it knows all that stuff. On the right-hand side, let's say as a developer, you can't modify your template or your theme to have those classes in for the divs or for whatever. You can actually, at the top or bottom of the site, you can include a bit of JavaScript, and that is all defined through schema.org on how it should be laid out and what information is required and what's optional. So it's the same information, just a little bit different formatting. Going back to this slide, there's a lot of APIs out there. One good resource for, I guess, all federal and local data in the US is data.gov. So you can use the government data for testing or abuse it. It really doesn't matter. It's not abuse. You're just downloading it and manipulating the files. You're not pushing anything to the site. But this is a good site to go to if you wanted to test out API calls, and maybe you can make some correlations to data, or maybe you can tie into the agricultural side of it. And I'll show you an example on that. So before I jump into it, calling APIs like JSON APIs with Excel, you're going to need some VBA tools. One of them is going to be that GitHub link, VBA-JSON. And then there's some other useful tools. This one's pretty good for parsing out JSON just so it can organize it or beautify for it. But if you Google for JSON Beautifier, you'll find it. So let me get out of this slideshow, and I'll show you a couple examples here. I'll pull Excel up. Now, these examples I understand might be a little, like this one might be a little contrived, but I'll show you another example that is actually a project I'm working with to see, to help out a customer. So I'll show that example in a bit. But this one, I just want to show you that I'll show you how to do this, but this button, when you click on it, it returns JSON. And then you click OK, and then it's going to return some content for the JSON. This new button is just another example. But to open up the Excel application and get to the developer tab, if you guys don't see this developer tab here, just right click anywhere up on the ribbon and click customize the ribbon. You'll then want to, on the right hand side, you'll see developer, check that box, and then it'll pop up with this developer tab. So this allows you to insert buttons like I did down here, and macros and everything else. This code behind the scenes, you can right click on it, you can go to assign macro, and then you can edit it to get to the code, or you can click view code. That'll pop up this prompt. This is the code for pulling down JavaScript through Visual Basic script. Now the way I did this is I downloaded that VBA-JSON tool, which is here. So go to GitHub. They have examples, and I'll post this in the description and everything too for you guys. But they have examples, and then down at the bottom they have the installation instructions. So you download the file, you import the BAS file, then you add the dictionary reference for the scripting runtime. So once you have the Visual Basic application open, you can go to File, Import File, and then import this JSON converter. This is the downloaded file from the website, from GitHub. Import that, and then go to Tools and References, and you'll want to check the Microsoft Scripting Runtime. That's required for this file. There's other libraries and references that you can use in your files, such as HTML object library is great for parsing out stuff. Let's see, and then there's another one that I did. Oh, the database provider, so you can connect up to the databases a little bit easier instead of going through Excel. Now, a lot of this stuff I understand is not like you don't need to use Visual Basic to do it. Visual Basic provides you a way to manipulate the information before it gets there. And to step through this subroutine here that I have for JSON click, we create a win HTTP object and set it to my request as the variable. And then we call the open function, pass in a couple parameters. I'll explain those in a second. Send it. And then we just simply pop up a message box. That was the first one you saw. On that first response pops up. The second response is down here. So I'll pull this to the side. So we initiate a JSON as an object. So we're saying that this variable is going to be an object once we set it. So we set that, and we run JSON converter, parse JSON, and we parse the request. That takes all of this, which is just a big text blob, and it moves it into an object. So then we can do things like JSON to get the body. So when we hit OK, it's going to go, it's not 0 indexed for whatever reason, but it's going to go 1, 2, and it's going to pull this body out, the EST, NATUS, and it's going to echo that out or put that into the message box. So I know it's a little contrived, but this allows you to access anything in that array, or in that object, I should say. So we hit 4, and it's going to change our body. Now, the cool thing about what's happening here is you can Google any of this stuff to get more information. So for example, like WinHTTP, if you want to know more about what that's doing, or even create object, you can head over to Google and type in VBA WinHTTP. We go directly, I would skip over the Stack Overflow stuff because that's a specific question. Go right to the Microsoft documentation, and you'll see, let's see, you'll see, okay, it comes up with the references. We have the object reference and the API reference. If we read this, we're not interested in the API reference because that's for C or C++. However, the object reference is for Visual Basic and scripting languages. So COM objects, everything like that. So it tells us, okay, the WinHTTP request. Here's the events that happen, methods that can be called, and you might recognize some of these. Put it side by side here. This is going to be open and send. Those are the ones that we're using. We're using those methods. So I can click in through here. It's going to tell me the syntax that's involved at the C++ level, which is kind of cool. And it's going to tell me the parameters that are needed. It needs the method. That's the HTTP verb, so we're doing get, and the URL. And here's the URL. And then for send, let's see the send method parameters. We could pass through a body for like posting or putting anything to a server, which is pretty cool. And then we get a return value, which is just a yes or no. So that's why up here I'm not doing anything with it. But the response text is let me go back. It's going to be a property on here. So there's a property on this object. Here's response text. It's a read only, and it's the entire or the entity body as text. We could stream it. We could get the response body, which it looks like is it's just an array of unsigned bytes. Status text, so 200 would be returned for this one if you wanted to do any checks that way. My point being, I encourage you to look at the documentation for whatever it is that you're working on. They're going to have good examples on what you need to do. If you need to pass credentials, looks like you could do set credentials. Click on examples. They'll walk you through. This is a C++ example. So if you are integrating with C++, you could use that. Here's a JavaScript or JScript, they call it. I don't know why. JScript might not be JavaScript. I don't know. But they walk you through this example. This is essentially what you could use in Visual Basic. It's a little different. WinHTTP REQ is their variable name. However, open, that's the same thing as open here. Now, JScript and VBA is different syntactically, but it's the same call. You're getting a URL. The target URL looks like is set probably a little bit higher up here, right here, and everything else is kind of the same. So I encourage you guys to look through the documentation. The other one would be like if you do VBA create object, because that's called on line 1 of that subroutine or line 2 of the entire VBA. So the create object function, it'll familiarize you with what's actually happening. You pass through a string of a class, and then it's going to return that object. So for here, it's actually creating an Excel sheet object, and then you're allowed to manipulate that object however you want, or however the object defines itself. So that's kind of what's happening at the bottom part here. JSON converter parse JSON is returning a JSON object, and then it has methods that we can pass to it, or it has methods that we can pass parameters through to it, and it'll return what we need from the message box. Now, like this is all kind of a contrived example here, but here's a real world example that I'm working on for a customer. Now this one is going to be returning is going to be making several API calls for UPS and FedEx and other shipments. And what this customer wants to do is determine what is the best way that it could ship out, that a shipment needs to ship out. So it's going to have several API calls, and they primarily work in Excel. So it's probably going to be living in the Excel world and be able to run on anyone's computer. So this one has some challenges to determine the best price and also get the most accurate pricing, because APIs are complicated, but that's where you have to go in and learn the documentation for it. But I wanted to show you this as a real world example. I can't unfortunately click through any of it because I just wanted to show it as an example. I didn't want anything to be like shown or revealed. But you will use, like on that example, I'll be using Visual Basic to manipulate all the data that's coming back instead of just standard Excel function calls. And you could write, instead of a subroutine, you could create an Excel function or a new function that is just easy for the customer then to say on Excel, say equals your new function, and then pass in some parameters. So it makes it easier for customers to get stuff done. One thing that I kind of skipped over was this URL. And I wanted to explain what that URL is. It's actually it's called JSON placeholder. If you Google it, you can find it, but it's a great fake API. So they have examples on their website, and it returns JSON data, just dummy placeholder data. And they have different resources such as posts, comments, photos, to-dos, and that's all I'm doing for this call. Is I'm just returning all of this data. Now, the other thing is that sometimes you'll get data that doesn't look good, and I will show you. I'll show you an example. This is my example, so I don't feel bad about showing it to you. This is the Shipwise API. It just returns, it's not meant for humans to read. It's meant for machines to read. So it returns all this gobbledygook. Fortunately, there is a thing called JSON Beautifiers. So you can just paste that whole one-liner in here, click Format or Beautify, and then it makes it really easy to find out, oh, this is what this is an object of 12, has an index of 12, and you can drill in and see, what are the properties for state? That's not that exciting, but what are the properties for order? And then you could figure out what level you need to make the call in for for Excel. So if I wanted to make a further call into an object, you could just keep passing in these prompts. But you'll only know that based off of what the schema is, what that JSON schema is. I wanted to jump over to Google Sheets because Visual Basic isn't used too much anymore. There are some strange circumstances, like I showed you that example with the customer, it's a business requirement, so it might pop up every now and then when you're working on things where you need to use Visual Basic, but otherwise I would encourage you to use Google Sheets. Google Sheets, since it's written in JavaScript, is a lot easier to use than Visual Basic. It's web driven, so it's going to be easier to manipulate data, and a lot of the data is already existing in some way, shape, or another on the web. So in Google, if you just create a new document, and if you wanted to learn more about what functions are available, you can click on Insert and then Function. You can click Learn More and read their documentation. I highly suggest it. But we'll be looking at web functions. There's one called Import Data. And the nice thing is that when you are importing data on a Google Sheet, let me get a couple examples of the data here. Let's see, import data. So all you have to do is pass a URL through it, or to it, I should say. Like in their example, this is going to be importing, that's terrible. Sorry. There we go. Need that equal sign. Importing this census data. So this is just a CSV file that's available on census.gov. Again, you can go to data.gov and get any data set. Use data.gov. We'll try pulling some other ones here shortly. And if you hit enter, Google Sheets just pulls it down. This is literally the CSV file. You can manipulate this data, change the data however you want to display it. It's really, really cool that they allow that Google Sheets has this built in. So if we wanted to, let's say, do this feed grains database, whatever that is, by the Department of Agriculture, you can right-click on. Looks like that's a zip file though. Zip file of CSV data. We'd have to do additional parsing with that. This one might be not a good example. Let's go to a different one. So let me pull up another example that actually has maybe a CSV file or fruit prices, vegetable prices. Web page with links to Excel. Perfect. So we'll go here. As links to Excel. This is a CSV file of, looks like, average retail price per pound or pint or per cup and per cup equivalent of apples. So we can go, let me close out of some of this stuff. Go back to our sheet. Yeah, and I'm just going to put that, copy that in here. Looks like this is the CSV file that's going to pull in. We hit enter and it pulls all that data in for us, and we can manipulate it however we want. So hopefully you're looking at this and watching this and thinking, wow, that's a lot more power than I thought was even possible with Google Sheets. We can really manipulate we can use this to our advantage, or come up with, if you're a business and you're interested in apple prices, average apple prices, maybe you want to know how much you're spending, per pound when you're buying apples in bulk or whatever, or applesauce in bulk. So there's a lot of cool things you could do with that. That's just with the import data part of it. Import data has its own thing, and its own documentation for how to fetch all the data. But they also have other items such as like import HTML, and import HTML I think is really, really cool, because what it allows you to do, let me delete that, is it allows you to parse out, I did not want to do that. 1 second here. Okay, so import HTML allows you to parse out anything. Well, really, tables or lists, really. So I'll just use Google's example here. But what this is saying is, go ahead and fetch this URL, demographics of India. Give me the table and give me the fourth one. So I want the fourth table in that list. And what it returns is the total fertility rate in India table. So if we go to that, we already have it. I already have it open. We go here. The fourth table is going to be, this is the second one, third, and fourth. It's pulling this information. That's really cool. If any of that information changes, well, not if the information changes, but if we go back to this Google Sheet on a different day or whatever, it's going to pull that information again. So that's really cool. If we wanted the life expectancy of India, we can go back up to here and click, type in 5, and that indicates the fifth table. And it pulls that information down. Here's the years, and here's the life expectancy in India, which, why did they stop at 1950? Wow, that's weird. Maybe that's the only information they have for it. So we can continue going on. You want to get the census data for it, just change it to 6, or have different, we can, what we could do? Just put this on this one, change it to 6. It'll pull in that table down here. Now we have the census year and the population with the growth. And we can graph this out. We could chart it, whatever we want. So definitely look at Google's documentation for all the web stuff. They have feeds, importing XML, and everything else. If you wanted to take this data further and manipulate it like we were kind of doing in Visual Basic, click on Tools and then click Script Editor. This is all JavaScript. So it's going to pop open, they call it GS or Google scripting. So you have to look up the GS code manuals, but you can create your own functions to go through and parse out the data that you need, or maybe pull the data every hour or something like that and run it. So this will empower you to do, to kind of be able to do anything and import any type of data that you want through Google Sheets or Visual Basic on Excel. So that's the end of the talk. I hope that it kind of inspires you to look at APIs in a different manner, look at Excel in a different manner. So when, let me find this one. So when a business comes to you and says, hey, we want to do this in Excel, maybe you won't be so scared to do it. You could do it. I might end up programming a website instead of doing that because it's a little bit easier to manage that data. One quick note before I leave is I mentioned schema.org. This is the canonical source put together by Google and Microsoft and just kind of everyone that's big on the web. But this defines how to organize your data. So if you're, we were talking about the Farm Aid event. If you want to know how that data is organized in Google, this is how it's organized in Google. They give you examples, and also most places on the web. They give you examples of how that data should be organized on your website or JSON link data again. So I pulled these examples off. And then they give you examples for like when events are canceled, what it should look like. If you mark up your websites with this data, and I know this is kind of unrelated to the talk, but kind of related because it's APIs. But if you mark up your websites with this data, it'll start pulling through. So one of my buddies, Ben, who works with the chamber, did this recently for easttroy.org, and all these events are coming through because it's marked up on the website. So you, I think if you click into this, it should go to the easttroy.org. Oh no, it just shows events. Okay, but all this information is coming through from schema.org.